Exactly. It's a triangle.
Oh yeah.
I hate you guys.
I don't see a triangle. I see words.
She said, wait, did you get it?
Yeah.
Oh, this. Yeah, but.
I don't even. Why do we have so many going to circle notes?
They're all okay, for 4, you need to know that this is looking for S. But theta always needs to be in radians, so you need to convert your 45 to radians. What is that in radians? Pi over 4.
That's not why. The only ones we're going to get close look. As a kid, like my nose not really good at classes right now.
Oh my gosh, good job.
So when you multiply that, if you left the pi, it would be 0.55 pi. You cannot leave it as 2.2 pi over 4. That's a weird fraction. Or if you just divided it all, including pi, it'd be 1.73 meters.
Wait, so you can't leave the infinity?
You mean like this?
Yeah.
No. You can't have decimals and fractions.
Isn't a decimal a fraction?
Yes.
So you can't have a decimal.
So that's a fraction over.
Yes.
That's a fraction in a fraction.
Yes.
You can't have a decimal.
What the?
Same thing.
The fraction's a decimal.
Oh.
Wait. Okay, I was right. I just had it right.
For what?
Right. For 5.
CSC.
We need to find the inverse of this function. So we did inverses a while ago. How do we start this?
You switch the X and Y.
And then you're solving for y. So I can subtract 2. Get rid of 4/3 by dividing or really multiplying by the reciprocal. That's supposed to be a parenthesis. I think in my answer key I did this one way when I distributed, and then I did it one way when I just left it. Either way is fine. And then take the cube root of both sides. I'll show the other way with the distribution as well. So either one. Yes.
Three. Oh wait. I don't even know what I'm so confused. Wait, you go.
She said I can't tell you what I'm asking.
Oh, you multiply by the reciprocal. Yes. So you can multiply by 3 instead of 3/4.
You could do that, but then you'd also be dividing by 4. You're going to do the same thing.
Okay, so it's the same. Wait, no.
he's making the
You know, the problem
So one is just distributed and one is not. Are you without a share?
Oh, no, Grant came over, so
It's actually good.
yeah, you gotta go back.
Yes. That's what I was about to talk about.
Oh, the test and the crash. No.
I lost you.
So if you think back to before winter break, somewhere in December we had 2 2-hour delays. We had a snow day, and that threw us off a lot. So the end of this is going to feel really rushed. That's not really my fault. I'm sorry. There will be something that I'm going to make optional in here, and we'll talk about that as we go.
Like the test.
No, there'll be a quiz that'll be optional.
Oh.
So we started drafting trig the last day before winter break, but we didn't do very much on it. So we're going to continue that today. I'm hoping that we get through those notes by Thursday. That is my plan. Plans change. And then my plan in your calendar was, well, one, to do a quiz on the stuff we had done right before graphing. So that was kind of like the stuff on your SharkBite, the finding the exact values of your trig functions and things like that, combined with the graphing trig. So if we have time, if we get there, I may make that a take-home quiz to be due on Friday, which means I would need to make a quiz. So that quiz is, I don't know if that's going to happen yet. It might, it may not. Which means if we finish Thursday, and if we finish Friday, that's okay too. Then we can test Tuesday, Wednesday of next week, giving us Monday as a ask questions if you need it. The end of the quarter is the 24th. So we need to test and review for the quarter test and test the quarter test within the next 3 weeks. So if we test the 14th, 15th, then we can review for the quarter test the 16th and 17th. Then there's Martin Luther King Day, which is Monday, the 20th. So then you would have the 22nd through the 24th, review 16th, 17th, and 21st, and then quarter test 22nd through the 24th. We okay with that? I mean, probably not, but.
I did this. Really don't. What is it? It's gold.
I have extra.
Did we start them already?
Yes, we did.
I'm so good. It's not those ones.
I do need your SharkBites back, SharkBite answer sheets back. So I will post those dates on Edmodo so that you have them.
Never seen this.
And then pass up your SharkBite answer sheets.
Oh, it's
If you do not have those graphic trig notes, raise your hand. I will get those to you. I know some of you weren't here.
It's not this. I'm sorry. Is there a pen?
I was like,
Wait, I remember writing this. Maybe I just didn't remember. It sounds like something I did.
Was there other hands?
I have a B plus A. She's making me so nervous. Wait, seriously? I have an 87. I literally try so hard that class. And no matter what.
Yes.
Is there any way you can do a quick review of what all this means? Just like, I don't know.
So the first piece, the first section of this is just your transformations. We just went over what those were.
Like when you're on a crash, like those up and okay.
And then the rest is just vocab.
Okay. Thank you. Sorry.
But we're going to repeat this vocab a lot when we do these, so don't worry too much about that.
Oh, you did it.
So you'll see these functions in two different ways. Sometimes you'll see x, sometimes you'll see theta. They mean the same thing. Same thing with all of our other trig functions. Sometimes you'll see x, sometimes you'll see theta. It means the same thing. So we're going to start off by filling up this table, and that's going to help us graph our function. But we need to know some of our unit circle stuff, so I know it's been a minute. We're going to use these x values, or these theta values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Mainly because all of our others, we get 1/2, which wouldn't be hard to graph, but then the others are root 3 over 2 or root 2 over 2, and those will be difficult. So we try to stay away from those. What is the sign of 0? Zero. The sign of pi over 2? 1. The sign of pi? Sign of 3 pi over 2? And the sign of 2 pi? So those are all from your unit circle. We didn't magically pull those out of the air. They all came from your unit circle.
Wait a second.
So when we're doing our sign, we need to remember that it always starts at 0. It's alternating 0, 1, 0, negative 1, 0. So now we're going to graph those. But when we graph these, we are going to use from negative 2 pi to 2 pi, just so you see that it continues and it repeats itself. We talked about that a period, I don't remember the actual definition that it said, but within a period, it repeats itself again. So I'm literally just going to plot these points. Be careful because this is really spaced out. Pi over 2 is in the middle of pi and 0. So that would be one period of this sine function. But because we can go around and around in both directions on the unit circle, this is going to keep going on forever and ever in both directions. So I'm just going to continue this really going backwards. I could think of this as negative pi over 2. Well, sine of negative pi over 2 is the same thing as sine of 3 pi over 2, so that would be negative 1. Sine of negative pi would be the same thing as sine of pi, so that would be 0. Sine of negative 3 pi over 2 is the same thing as sine of pi over 2, so that would be 1. And then sine of negative 2 pi would be the same thing as 2 pi, so 0. It repeated itself again. So each time it repeats itself, that is one period. It takes 2 pi units to repeat itself. So I know that one of the words we talked about was amplitude. It measures that distance between your midline and your maximum, or your midline and your minimum. So if I was looking at my midline, that would be the point that it keeps coming back to. And in your notes it says that's affected by any vertical shifts. Well, this is the parent function. It doesn't have any vertical shifts. Below this table, just write your midline equals y equals 0. Y equals 0. So anytime you have a vertical shift, your midline is going to change. You can look at your amplitude from your graph or from your function. From your graph, if you're looking at your midline, you can look at your distance from the midline to your max or min, and that would be 1 here. That one's a little off, but it should be 1. Or if you were looking at your, function, any number that is being multiplied to your function outside, that would show how much is being vertically stretched or compressed. So that also is your amplitude. Here there aren't any numbers, so you can assume it's still 1. But because amplitude is a distance, it always has to be positive, even if it has a reflection. On the first page, it talks about how to find your period. So if we have some b, which would be inside this, so I'm going to write this off to the side. This is on your front page, but I'm just writing it again. I think I actually made them H and K, sorry. So if you have some number b, that's going to change your period, whether it's being stretched or compressed. In this case, we didn't have any b. We can see that it repeats itself every 2 pi. So you can either look at your graph and see how long did it take to repeat itself, or you can use this. Well, our b is 1, so our period for this is 2 pi. What's our domain? All real numbers. And then our range? -1 to 1, because it's not going past those 2 values. And those are included because it is touching both.
The formula was on the
What'd you say?
Oh, plus K. Oh, I thought you
I did
next
put
part.
plus D, but I changed it. But no, I just wrote it tied up. Okay. So your range is going to be changed anytime your amplitude changes and anytime you have a vertical shift. Yeah, really both. In this case, your x-intercepts are all of your multiples of pi. So this is written kind of weird. So that means whatever number I multiply to pi, whatever multiple of pi, it's going to have an x-intercept there. Yes.
What is that one comes after pi there?
Okay.
Oh.
That was a good
Thanks,
one.
Ryan. Thanks.
Multiple of pi.
Multiples of pi.
He said, oh.
What's your y-intercept?
0,
0, 0. So for the most part, you should be able to fill out your table without really looking at your graph, because you could really look at your function to find most of these. The x-intercepts change, so that one you kind of need to look at your graph. The y-intercepts, sometimes you can use your graph, sometimes you can just use your function. It just depends. Now, does it matter whether you do this first or do the graph first? No, but you should be able to do most of these without looking at the graph. Questions on your sine function before we do cosine? Right. Same thing, this could be f of x equals cosine of x or cosine of theta. I'm not going to write both, but they could be the same thing. Same x values. What is cosine of 0? 1. Cosine of pi over 2? 0. Cosine of pi? Negative 1. Cosine of 3 pi over 2?
0.
And cosine of 2 pi? 1. So it still has that alternating, but it starts at 1. So 1, 0, negative 1, 0, 1. So if we were to graph that one, it would start at 0, 1, go over pi over 2, 0, pi would be negative 1, 3 pi over 2 would be 0, 2 pi would be 1. And it would look something like that. So it kind of looks like the sine function, which we talked about, that sine and cosine are basically the same, it's just a horizontal shift. Or a phase shift. Phase shift is our new horizontal shift. And then we could do the same thing backwards. So negative pi over 2, it would be 0. Negative pi would be negative 1. Negative 3 pi over 2 would still be 0, and negative 2 pi would be 1. Those are supposed to be arrows at the end. So again, this still has that midline at y equals 0. It's still controlled by your vertical shift. We don't have one in this case, so it's still going to be y equals 0. And really, these two functions are the only functions that are going to have this midline, sine and cosine. Because it needs to be a sinusoidal, the ones that look like these, function. It's really just, it's just a line. I think the actual definition is... Oh, this one. What would the amplitude of your cosine function be? 1. So if there are no vertical stretches or compressions, it should always be 1. Your period, still 2 pi. So if there's no b, those won't change. Your domain, still all row numbers. Your domain, or I'm sorry, your range, negative 1 to 1, still the same. What about your x-intercepts? don't try to figure this part out. Where do you see them at? All of your pi over 2. So this one, it's actually weirder than that one. Pi over 2 plus pi k, comma 0.
What is pi k?
Basically, it basically just needs multiples of.
Wait, pi k. Sorry. Are we expected to remember that?
No, like for the test. No, just know that it's multiples of pi over 2, or pi, or whatever it is, if it changes. What's your y-intercept?
0.
0. Alright, so the very last thing we're going to do, we're going to do 2 things, because I want to show you something really fast. So this is that triangle moving around your unit circle to make your graph. All of those things are still connected. If you get on this, you can change your amplitude and all of that stuff, but I'm not going to. So yes, it would keep going forever and ever, really in both directions. We're going to do this really fast. This will be the last thing we do. I'm going to do 2, you do 2. Let's do this one. What would the amplitude of this be? Can't be negative. And it's always the number that's being multiplied to the front.
2.
So it's just 2. So it's always the absolute value. We just never include the negative because it's distance. And then for your period, we have a b now. So to find that new b, you would do 2 pi over that number. Now this one happens to be a fraction within a fraction, so you need to multiply by its reciprocal. So that means instead of going the full 2 pi, it's only going to go to 3 pi over 2 and then repeat itself again. So it's been horizontally compressed. What would the amplitude of 1 be? It would just be 1. Your period would then be 2 pi over 4, so just pi over 2. Again, it's been horizontally compressed. Now it's going to repeat itself every pi over 2, so it's very, very small. Try these other two, and then back up.